but it's definitely erroring a lot, right? So, and my stop button doesn't work. So, hey everyone, welcome back to Daily Standup. Today I want to show kind of where I'm at with all the notifications and also my new section I'm adding for distributed logging. And so I'm going to basically run through kind of where we ended last time with the performance profiler. So this is connected to my backend via WebSockets. You can see on the side the WebSocket connection to my backend, and I'm just going to start making a whole bunch of requests. So I added this box on the bottom just to specify a number of requests I want to make per minute, as opposed to having it relying on my engine right now. So you can see the notification came through, warning engine overheating, and in a second it's going to say engine overheated right there. So it's all in real time, and again, that's processing through my Rust microservice. You can see here, it's doing a lot of the kind of the back-end work to make that happen. But the next thing I'm adding, so I'm actually going to I'm going to refresh. I'm going to go back to here, and then I'm going to re-kick this off. So I'm going to have it start sending 1,000 messages per minute. So start requests, and I'm actually going to route backwards and go to this logging page. And you can see it's empty, but we'll give it about, okay, right there. Give it a second. So then this, basically the idea for this page is going to be distributed logging on a dashboard. So how I want to do this is, hold on, let me stop my requests here real fast. But I'm going to go back, and obviously it's going to wipe out the logging. But basically what I want to do is, since I have all these services, I have my front end, I have my back end, I have my Rust microservice, I have my RabbitMQ server. I have a lot of these microservices running, and I'm just going to be adding to the number of microservices. And one of the difficult things in software is just keeping track of basically the start of one request, how it routes through the whole system and makes its way back. You can look up distributed tracing. .NET has examples with OpenTelemetry you can use. I like to build my own personally because I like to just incorporate it into my front end on a dashboard. So basically how I'm thinking this is going to work, I'm just going to create another RabbitMQ queue called logging. And you can see here, this is my RabbitMQ logging queue. And for right now, the message structure is just going to be JSON for message and source. Basically, the log message and then the source, so the system that it comes from. So I wired up so far my Rust microservice to send a log to that logging queue right here, to send a log and have the message be log shutdown, and then also the source be my Rust microservice. So this is, obviously I'm going to add details as I go, like some kind of ID or something like that, so I could stitch them together. But how I want this to work is that logging is honestly a pain in the neck because, as you grow the number of systems you have to tie more of the requests into each other. Usually there's like a correlation ID, there's some kind of like session ID, maybe there's like a trace ID. There's a lot of different IDs that you can use to do this, but a lot of that kind of takes manual steps to correlate, one request to another, based on IDs or timestamps or whatever it is. So I'm thinking that I just want to make a queue for my system to house all the logs, and then basically I want to stitch whatever's in that queue to be put on this dashboard. So how I'm going to build this out, obviously it's blank right now. I literally just started it like an hour ago. So I just have made my queue and my SignalR hub, and then my my RabbitMQ consumer. So just kind of I'm just kind of wiring up kind of the skeleton of this so far. But how I want this to be is essentially how this is. I want everything to be in tiles, and I want to show a route for each thing, so that way you can see exactly the steps that it took. So in this case, for how I want to do this is that when you go to this profiler, this is when you start making the requests. It's sending a whole bunch of requests up to the back end, so this home controller. So that's step number one, right? So I want to have a log message from this home endpoint to my. I'm going to send it to my RabbitMQ, a logging queue. That's step one. Step two in this whole thing is the Rust microservice. So Rust is going to be consuming my be consuming my engine's queue, right? And then parsing that, doing whatever logic it needs to, and then ultimately it's going to be responsible for sending a potential message up to the notifications queue. So this is step two. So Rust needs to have a log message for whatever it's doing, and it needs to correlate back to whatever request or whatever message that it read from the queue. So I want to basically say that I want to correlate the exact moment in time of my front end's message. So I'm going to give it a message ID probably. So I'm going to give it a message ID of a GUID or something like that. But for this example, it could be like 123. So the logging queue could have a message in there called or with a JSON structure with an ID of 123. And then it's going to have an array of message. So then Rust is going to, when it sends its message up to, or when it sends its log message up to the logging queue, it'll check for that key, and it'll have the ID, and it'll say, okay, because the ID is going to be on the engine model that it's consuming. So it's going to take that ID. First, it's going to check if the logging has it up there. If it does, it's going to add to that message array. So all of a sudden now you have a message array in your queue that's built on .NET and Rust. So now you can correlate. It'll just work. And I'm thinking there's a couple ways to do this. So either I have to keep the queues in the queue messages and like just basically it's a queue, right? So it's just going to be a queue structure. So I think I might have to do some of the logic on the consumer end. Basically, actually I might, now that I'm talking about it, I think I might have to do it that way. Basically, I need this consumer here, this logging consumer. When it reads a message from that queue that it gets, it needs to have a data structure that supports adding based on a key, so like a dictionary or something like that. So if a dictionary contains 1, 2, 3, and then an array of messages, if it contains that key, it's going to say, okay, add this to that element, and then if it gets another one, add it to that element again. So and then the front end is going to display that in a way where it's all just tiles. So it's going to be real time, and obviously I'm going to add persistence to this so it doesn't cancel out every time you route backwards. So every time it would add to that dictionary element, it would be a box, right? So box 1 for .NET, box 2 for Rust, box 3 for our Python microservice that we're adding, box 4 for whatever else, and then you can just stitch it all together. That's like ideal state. And that's going to just be a dashboard on here, so you can just pull it up whenever you need to, just to say, okay, if there was an error, we can see exactly what happened and what state it failed at, as opposed to having to go through to each system manually and try to decipher where the error occurred. So I'm going to try to build this out as best I can, because honestly, it's just easier for me to keep track of everything, and I already know I need to put logging in place anyway. So I might just try to create this somewhat form of like distributed tracing using a RabbitMQ queue. So we'll see how it goes, but I really like to make it visual. That way I can just go to logging and then just click on a square and then see the data as it was in that system. So I think I can do it for sure. Truthfully, I don't see why I can't. I'll just have to be selective as to what I'm logging, because since I'm sending so much data to the back end, I'm not going to log 6,000 messages a minute, especially if it's all the same data. So I'll have to be selective. So I'm going to have to just log. I'm just going to have to log specific events. Obviously, I'm going to have to log error events. I'm going to have to log like notification events. So if I'm sending a warning message, I'm going to log that I sent the whatever warning message it is. That way, I just have an event log. Okay, to see. Okay, this message ID at this time in UTC time, this produced this, and I have a record of it, a log record. Obviously, I have to make it persistent, so I might have to set up a table to do that for me. Maybe, or maybe I could just I don't know. There's a few ideas, but hopefully that makes sense. Kind of start getting into the weeds pretty quick. There was another thing that I tested actually the other day, which is pretty neat. So I'm kind of testing like the breaking point of like how many requests I can send, and I'm actually going to show you guys this right now. So I have everything running, I think. Rust.net, and yeah, okay. So everything's running. So I'm going to tell it to fire 6,000 requests a minute, and we can see what happens. So you can see this is going good, and so you can see the console requests, making a request, and we have no errors, and we've gotten all our notifications, so everything's working fine. But you're going to see in like a few seconds that this finally consumes a ton of resources, and yeah, you can see it just failing out right there, right? It's insufficient resources. And you can see my error rate is just climbing and climbing. And I think I think it's able to still successfully send some of them, but it's definitely erroring a lot, right? So, also my stop button doesn't work. So I just have to go back and refresh. Also because I'm still working on the routing. So if I refresh, it's going to try to go to the back end and then not recognize a route. So that brings me to my next point, is that I want it to be capable of handling more messages than that. And truthfully, I don't really need the response back from like what you get with an API. So I might actually look into either calling my RabbitMQ directly, which is possible, and kind of avoiding using my back end with mass transit. Might be a possibility. I might see some improvement there. I might use. I may also experiment with trying to. Since I already have SignalR set up, I might just use WebSockets to send these requests. Again, because I don't necessarily need a response, or even an acknowledgement at that point, or at that rate. So, but I like to make this like toggleable. You know what I mean? Like I like to keep this like, if I want to use API requests, I can leave that on. If I want to switch to use WebSockets, I can leave that on. If I want to go right to RabbitMQ on the AMQP protocol, I can do that. I like to have that set up. I think it would be really neat to experiment with that, and I think it would be really, really beneficial just as like a testing platform in the future, just to illustrate load testing on a system locally. And I think it's really neat because we saw it here. I was able to hit 1,000, like, and then it's like once it reaches that threshold of erroring, it just goes crazy. So I think so. That's like the next thing I like to set up for sure, if that makes sense. One, because I'm kind of interested in it, but two, I'm trying to crank the number up as high as I possibly can with no errors. Because I want my engine simulator to be as close to realistic functioning as I possibly can. So I was trying to send 6,000 requests a minute, which is pretty close to a two-stroke running on wide open throttle. I forget what the I forget what the idle RPM is, but it's probably going to be more around like 4,000 RPM on average. So again, it's under that 6, but if I can't send 1,000 before I start getting errors, that's a problem. So we're trying to get to 6. That's the goal. So we have to be a little creative in terms of how we're going to do that. And this is pretty neat because it's really realistic to like real world scenarios of like sending data and how do we kind of push the boundary to how much data we can actually send. So we're going to change that. We're going to add a setting to make that toggle. Where this is going to get annoying is that because I'm using mass transit on my back end to send to RabbitMQ, that has a very particular structure of data. And if I switch to using just a direct connection to RabbitMQ without mass transit on the back end, it's only going to be sending up the JSON that I want it to, which is actually a positive, but my Rust microservice is set to check for the message structure of mass transit. So what I might end up having to do, to be honest with you, is I might end up having to make another basically copy of my Rust microservice, which is fine, just have 2 running services, and have that one pointed to another queue that I'll end up making this connect to. It sounds convoluted, but I might have to do that. Otherwise, I'll have to add in a bunch of logic to my Rust microservice, and I just don't really want to run the risk of like messing that one up. The other option I could do, I guess, I could just copy the message structure in an interface and then just send that up to my RabbitMQ and hope that it all is there in the payload. Which actually, that might be the easiest. I might do that, to be honest. That might be the easiest way. Or I could just configure mass transit to not send up all its request headers and only send JSON, which actually might be better. To be honest, I don't really know when I'm using mass transit because I have no intention of changing the queue source. It's just kind of easy to configure on .NET, but yeah, we'll see. There's a lot. I got a lot of work to do, but it's really fun because it's super experimental and you can like see just like real world numbers with systems, and it's no different than it's honestly no different scenario. Like it's not really that much of a different scenario you would run into at like any kind of production setting. Like this is pretty much what you do. So, but yeah, once I get all this stuff then in place, hopefully we can start to mess around with our Python microservice. I've already started a little bit. You can see this. This was actually, I'm working on something for QR codes. So I've been working on this like new file. I have called it engine temperature because I fully intend to make this my engine microservice that outputs the temperature curve and graph. And I just want to take the graph and put it in a QR code. That way you can scan it and kind of take a picture of the graph if you want to do that. So there's a lot going on, a lot to keep track of. That's why we need logging. Hopefully this is interesting. But yeah, that's what I'm working on. So thank you all for watching, and I will see you on the next one.